Today we're going to talk about the use of LLMs, which I'm sure you all know what they are, in an healthcare space, and now Cardinal Health, Sonexus, Access and Patient and Support Services have worked with Google and Confluent to build a demo to show some innovation in this space. So this is who we are. So kicking this off, I just want to tell you a little story. So my two colleagues here, Marcel from Google and Pascal from Confluent, we were sitting at the bar the other night, and both these guys are actually naturally French speaking, or they can speak French, and they said, challenge one, Steve, today we're going to give the presentation in French. 15 seconds into my French, probably not even that long, they decided we're doing it in English. So you're welcome, Current. But when we're talking about French and all that, I kind of let my mind wander a bit, as you do when you're having a beer conversation. And I really thought, well, we three guys here, we're the three musketeers. But we're not Aramis, Porthos, and Athos. Really, the heroes in our story is Kafka, data streaming, AI, and Cardinal Health's experience in building enterprise solutions for the healthcare industry, right? So we are the three musketeers, but in a technology way. And then it got me even more thinking. It's like, well, Alexander Dumas wrote that story about 160 years ago, and we still know it. We're still talking about it. And I think the story that we're going to tell you today, Alexander Dumas would have been proud of it because it's really a great story. And at the end of it, by the use of innovative technology usage, what happens, we get people medical care that they really require. And at the end of the day, that's a great story. So with that in mind, there's three of us today. And like every good story, there's a beginning, which is myself. There's a middle, where we're going to talk about the underlying technologies that's driving this innovation, which my friend Merlin will be talking about. Then at the end, we're going to have some super cool demos that Pascal's doing. Then we'll wrap it up with a question and answer session. So what about Sonexus? What's the use cases we're trying to do? So Steve Gregory, I work for Cardinal Health, and I work for the division called Sonexus Access, Patient and Support. And what do we do? Well, essentially, in the most simplified terms, what we do is get underinsured and uninsured patients access to specialty drugs, the drugs that cost a lot of money, right? And these people haven't got the insurance to pay for it. So we work with big pharma companies on their patient programs, their PAP programs, patient assistance programs, to subsidize or give for free these drugs to get people the drugs they care. So our aim through technology is to get people, patients, on drugs quicker, increase their access to them, get there on quicker, and increase their experience, because working through the US healthcare system is a challenge. And let's say your specialty drug is for something like Alzheimer's, right? If you're a patient that's losing memory faculty, then it's even a bigger challenge, right? So we've got to make things easier, simpler, and we've got to bring technologies to bear that help the patient through this journey. So really what Sonexus does is create better outcomes for a patient journey, and we do it in our space for getting patients on patient drugs, but this is true across the entire gambit of healthcare. Healthcare is a very workflow-oriented business where there's a journey from a start, diagnosis, to treatment and cures at the end of it. So we're going to do at least 4 demos today. So the relationship between us started a couple of weeks ago, and our friends at Google and Confluent came to us at Sonexus and said, hey, we're working on this super cool stuff. You notice I'm not spoiling the story by telling you what it is yet. This super cool stuff, right? They said, would Sonexus be interested in this? Is it cool? Is it applicable? And of course, demonstrating my 3 years of high school French, I said, oui. So it wasn't a complete waste of time, right? So, but what I really said is, hell yeah, right? Because really this industry and what we do is screaming out for workflows, for AI, to drive automation, right? To reduce costs and to get people on their treatment. The other thing we discussed is in healthcare, the solution is not boil the ocean, right? We don't want an AI solution that cures cancer. We'd love one, right? But that's super difficult, if not impossible to do. But the value in such a workflow-oriented industry is you can apply AI to each step in the process. And you can save millions of dollars by doing that. You can save loads of time, and you can improve the quality of the patient journey and the treatment people get. So we're going to look at 4 use cases today that we'll demo, largely around patient assistance programs. But the other advantage as well is, and I'm always afraid to admit this in front of a large group of people, but you all look friendly, so I'll tell you. The fax is still our main method of communication. So we have a major problem at the bottom with missing information, right? And you can't process and automate unless you've got all the information. So our 4 use cases we're doing, as well as a use case our colleagues developed around COVID as well, is what we're going to walk through today. So I think that's enough of me talking. Let's get into the cool and exciting stuff. I'm going to hand over to my fellow musketeer now, Berlin, and he's going to work his magic on telling you all about how this technology enables great outcomes in healthcare.
Thank you, Stephen. Thank you, Stephen. So yes, this is the coolest part. Okay, so I'm Merlin Yamsi. I'm part of Google Cloud, Partner Engineering. I've been working in the AI for some time now, and people think AI is new, but AI has been there for a very long time, right? Things start with data and AI a few times, long time ago, and AI was mostly focusing on prediction, right? Predicting things, right? And then since recently, we're starting generating things, generating images, generating text with generative AI. That's kind of where AI is starting to be democratized, where people are starting to know more about AI. But we're moving ahead to more and more AI, where now we are looking for action, like AI can also act. So we are moving to the agentic age, where AI will be even more, not only generating stuff, but also booking your ticket or doing things, right? Acting. And to the quest to the AGI, we have on the way a kind of autonomous, personal, real-time AI, which will be part of what we call contextual AI. And that requires a set of data and a set of enterprise data that are needed to bring that to life. And that's where we are today. But before we get there, what have we learned from our customers' success story, right? So 4 key success factors when you build a Gen AI for enterprise, mostly, right? First, you need to have an enterprise platform. You need to think about a platform instead of just thinking about a model. Because the model is one thing, but you need the full stack. You need the LLM ops. You need the data platform. You need the data governance. You need the AI governance. You need security. So you need a lot of things above just the LLM, right? So that's one of the key things that we have learned. And you need optionality of choice, because at any point of these different layers, you need choice. You don't want to be stuck with only one choice. Second thing that we learned is that data is the foundation of most of the AI, Gen AI system. Because just going and querying and launching a query to an LLM is not enough to create something very powerful, right? So the data foundation is something that will help create even more something more accurate, something more focused, something more powerful for the enterprise. So knowledge is a key. Knowledge and data is something that is needed for AI, for building an AI, enterprise AI. The third thing that we also learn is that AI is something that moves so fast and so quickly that you can invest something today and tomorrow it's obsolete, right? So you need to work with someone that have a future-proof platform so that you can rely on, right? So because if you have something today that work, and tomorrow you have something else that is not working, so it could be very bad for building the AI solution. And then lastly, the enterprise readiness. Because once you build an AI, you build a demo, you build a POC, typically it's working, right? And then you need to bring that to scale. So then that's where you need enterprise readiness, scalability, security, governance, a lot of things that are needed, you know, to make the AI more ready. So those are the 4 things that we learned from our customer success. So based on that, so we kind of came up with a unified platform from data to deployment, right? And covering from predictive to generative to agentic. So keeping something that you will be able to leverage on in many years, right? You don't have to just have one thing today like predictive or generative or agentic. You have the 3 together, right, in one platform. And then you have data, which will be the key part of integrating that into the platform, into the AI/ML platform. You have the insights that you can get from a tool like Looker, or you can have a voice if you want to have an output as a voice. And then you have the platform, the governance platform, which not only do the governance for data, but for also cloud operations, but also for AI. So you have everything covered in the governance. End-to-end governance, infrastructure at the middle layer, at the bottom layer. So you have a TPU, GPU, you have the governance platform, and then you have the data to AI, so that you can build any type of solution on top of it, right? That building your own AI agent is part of creating something that's covered from the data to the generating the AI in scale. So this is a clear end-to-end platform that could be very useful to build many use cases. Like you said earlier, it's about building use cases. So you have a platform, a foundation that will help you do that. So the flexibility that I was talking about is more about, so you have the data layer. So there you have many options, right? You can, any company has a data layer that could be different cloud, different premise, or any type of data. You have the compute, it could be TPU, GPU, you name it. And then the framework, like TensorFlow, JAX, PyTorch, the model, which is one component. The model is just one component of the overall stack. It could be Google Gemini, it could be OpenAI, it could be Mistral, it could be anything that you think might fit the use case. And then the agent platform, which would then bring also some of the layers of framework to build the agent, right? And there you have many different type of support, LangChain, Llama Index, Vertex AI. So these layers are there, and it's very flexible. You can choose to deploy your solution leveraging each of these layers in a very simple manner. So now, what we provide at Google that we use for the demo is the Gemini on Vertex, right? That's what we use for the demo. That's something that we launched earlier this year, Gemini 1.5. We have 2 versions, Flash, which is the small version, more cost efficient, fastest. And then we have Gemini Pro, which is the more complex reasoning, and both have a 1 million context window, so you can put a lot in the context, and then it's running pretty fast. So now, when you build a GenAI application, right, there are a lot of challenges that you need to face. typically the data, up-to-date data. We were talking about that, maybe you heard about that this morning, the fresh data, the real-time data, or the near real-time data. This is something that is not embedded in the model, right? The model is up to probably like the last year or so. And then you need to provide more up-to-date data to the model, right? That's one challenge, that the data need to come in, right? The number two is the contextual user experience. So you have to bring not only the data, but you also need to combine the context, the query with the contextual information that the user is looking for. So from the data, you will extract that context, and then you bring that to the user experience, right? That's number two. And the number three is, how do you do that in an easier manner, right? How do you build that as a developer? How do you build and operate easily? So these are kind of the three things that we want to cover here. And for that, we have an architecture that has the foundation models on one side, the generative AI application on one side, and the operational data, which is the bridge between the AI application and the foundation model, right? So this is really what we call the operational data bridge, which bridge the gap, right? From just leveraging an app that we call a foundation model, you have to have a operational data in the middle. This get us to this architecture where you have the foundation model on the bottom line. So any kind of foundation model that you think will fit the use case, the tooling, the LangChain or GenKit that can be used to build, orchestrate the framework, the Vertex AI, which will host the model. We also try to use the modification or the updating or the customization of the models through Vertex AI, and also the tooling. And in the middle, operational data, this is where we are focusing today. So typically you have three main thing here, right? Vector database, vector processing, if we are looking for similarity search in leveraging embedding store, right? That's one way to get a query, to create embeddings, and to look for things that matches, right? And then we have the model access, like getting access to the embedding model, getting access to the model in Vertex that will create the summary, right? That's the way to access to the model, an API that you can access the model to. And then lastly, how do you create get the natural language and create an SQL, right? Because when you are dealing with structured data, typically data is in tables, right? You have the table, you have the schema, you have the columns. And when you ask the query, the natural language query, this language needs to be translated into SQL and then query the different data sources with joint, everything that needs to happen. So this operational data is what we will be seeing today, where we will have a platform that will be able to access to the model for doing the generation of the code or doing embeddings, and we'll be able to leverage that result to generate like a voice or something that will happen as the output. So Pascal, I think here you will be able to talk about Confluent. How do we do that with Confluent?
Aha, yeah. Secret.
Yeah.
Hi. That's very interesting. What you said at the beginning is so we started this project a month ago, something like that. The total time working on, if I were working full time on only that, it would have taken me maybe a week. Not because we didn't do enough work, it's because the tooling that's available with Google and us is awesome, right? So it was very fluent for me to use Flink AI, which is like an early access right now for our Flink. How I can say that? The Flink integration with models is very tight. So it's very easy for us to write and to create new models with our Flink AI on Gemini. And it was super, super easy and very, very nice. So the experience was great. One of the things that is very, very important to understand is for AI, what matters is your data, is how fresh your data can be, so you can give the information as the best as it's possible, right? So, and one of the good things in Confluent is like we bring data in real time to your generative AI to make sure that you get the accurate response from your models. One of the things is, like what I said, is a real-time integration, right? So I really like, and it was a very interesting experience for me because it was the first time I was using our Flink AI, and I'm not a Flink developer at all, right? I'm a background Java developer. I love Java, and I think it's very interesting. Like I was like, okay, I'm not gonna use KStream. I'm gonna use Flink, and I'm gonna see what I can do with it. And it took me a very, very short time to get used to the SQL because I know SQL like most of the software engineers in this market, right? So I just started like playing around, and in very, very few hours, I was able to create a model, just call my inference and get some results. The hardest part was, again, the description, the prompt was the most complex part of like the work I had to do, is to explain to the model saying, hey, here I have some table, and I will show you at some point, like I think I can show you if I can share my screen, like how the prompt looks like. It's like very details. You need to very specify what type of data you have, each column, and give a business description. So the AI was in generating the SQL, you know, which table to go to and what to do with your data, right? So that was super, super interesting. I have to say it was like a great experience. I loved working with those guys. So the freshness, again and again and again, and I will always say the freshness of your data. More data coming in real time, better your result is going to be, better your user experience will be excellent. So what did we do? So for the idea when we started was to, here I have some very complex SQL database, and I need to be able to give to a non-developer the ability to query your data, right? So that was one of the asks. And we said, okay, let's work on that, right? Let's make it happen. So, and I have to say at the beginning I was not really, hey, you know, guys, I don't know. And so that was the interesting part. So I never did that before. I did like tons of generative AI, mostly chatbot, RAG architecture, which I think right now we've been going over RAG architecture and over again. Everybody knows RAG architecture. When you are a bit aware of like generative AI, it's time to move on and have some more interesting AI stuff to do, right? So the SQL was very interesting use case because we never did that before at Confluent. We're talking a lot of RAG architecture. I think it was also for us a really good experience to just try to prove that with Confluent and the right partners, you can do more than just RAG architecture. You can do really, really interesting use cases. So we obviously use a Postgres database as a backend. We have Flink AI and Gemini doing all those beautiful generative SQL query. And the prompt, right? The prompt was one of the most important things. And I don't know if anyone here has experience with generative AI, but the prompt is the most important things you're gonna do in your no matter what model you're using, right? The prompt engineering, honestly, I think is the next gen of work, right? Some people are gonna get paid to make prompts, right? So it's something when you create your use case and when you want to expose generative AI to your users, it's super important to use a system that's capable to first, like one of the things I really love with Confluent and Kafka especially, is the replay capabilities, right? So you can do A/B testing with different prompts, different model. Let's say like one of the things I was doing, I started testing with Gemini 1.5 Flash, right? And the SQL query was not great. And I said, okay, let's do a better, more expensive, slower, and to get a better result. And I have to say, I was like amazed at the differences. But it's slower, right? But we get a better user experience. So one of the video I'm gonna play, I'm trying to do real time, but the Wi-Fi is not really good, so it's not working so well. So I'm gonna show you a video where it's interesting because we use also geolocation. And that's not that super, like I have to say, I never did geolog before. And like I was like the first time we implemented that in Postgres, it worked right out of the box. I just said like I need to have like show me the provider within 5 miles away from me, and he gave me the result. It was like really cool. So for the prompt testing, it's really cool because you can do A/B testing, change your prompt, test different model, and do the replay capabilities of Confluent, right? So you just like reset your offset, let's go for it, I'm retesting, and then at the end you can pick which has the best result. And then after that, you can go to production, right? So it's really interesting on that side. So what was the challenges? Really the schema of the database. And one of the next steps, so next year you're gonna come to Google Next, and we're gonna have a much better demo. So the idea is to have like 1,000 tables and different schema, and being able to leverage like some vector database and all those kind of stuff. I have tons of ideas. I'm so excited. So the complexity of the schema, it was very interesting because at the end of the day, I don't do healthcare, so I don't understand his world, right? I write codes, that's the only thing I know, and I can talk code with you guys. So the interesting part is like when I get the schema, there was some business description. I said, okay, yeah, we're gonna use that. That's helped me to understand the data model, but it's also helping the generative AI, right? And one of the LLM, it's interesting because the result you're getting is sometimes not the one you're expecting, right? So it's like a human. When you talk to someone, you said, hey, and you expect he's going to answer in a certain way, and obviously the answer doesn't make any sense because he didn't understand what you are trying to get out of that person. It's yeah, exactly. So the interesting part is at the end of the day, talk to your LLM, create your prompt the same way you're going to talk to a child, honestly. I don't know who has kids here, but I remember my kid, I was trying to explain some concept to him. And I was using the wrong prompt to my kid in some way. And the answer he was giving me was like, doesn't make any sense. What are you talking about? And I realized, in fact, literally, when you go to Gemini or any kind of LLM, just go and think that that person in front of you has a really little knowledge, right, on what you are trying to get out of it. So the prompt, and I will say it 1,000 times for anyone who wants to do some AI, is the most important things, no matter what model you're gonna use. Is like how you're gonna explain the problem and your outcome you're trying to get out of it. You have to be precise. Like one of the things I was testing is to get a JSON out of Gemini, right? And until I had to give an example of what I expect to get a proper JSON. Otherwise, he was giving me like some weird JSON and he was guessing what I want to have and stuff like that. Those kind of things is super important. And to avoid hallucination, the only thing you can do is to be precise. Otherwise, it's making up stuff, right? And the validation. So one of the things is also, like I keep saying, because I'm going all over the place. But like the way we describe into our prompt the SQL query, the table structure was really precise. And that avoids us to have like make up queries that doesn't really work, right? And you'll see in the demo, and after that I will try to share if we have time, the prompt. Or you can come to see me after and I will show you. There's not that many tables on that example for today, but it's interesting how precise and it works really well. I was really happy. So what you see here is kind of the architecture of the solution we use, right? So it's fairly simple. We have like a computer, you talk to it, we have an API receiving your voice, and then we do an audio to text. We go into a topic, and then we do a conversation. When we get the text, we go to a SQL using Flink, and the Flink giving us, so the Flink AI giving us the SQL query that we can run against a database, and so on and so forth, right? So it's all microservices oriented because I do believe in microservices, and I do believe in a smaller unit of work, right? So that's allow you to scale your different workload based on the need, right? For example, one of the things I noticed, audio conversion takes time, right? So if you do that all in APIs, you're gonna block your API call for quite some time. So you don't want to do that. So doing asynchronous microservices is one of the key where you can have your platform to scale as you need, right? It's allowing you to have your business growing. Because today, maybe you have 100,000 users, right? And you said, oh, my platform works well, it's all API driven, like everything works. And all of a sudden you are successful, you have 1 million users, right? Your scalability will be so different, and you need to have a platform which allow you to scale based on what you need. So scale up and down, right? And one of the Confluent and microservices architecture I really like is that. It's like the ability to like tune your platform the way you need and based on the demand of your use case, right? Next slide. And one of the cool stuff is like, after that, one of your staff said, well, yeah, what if I want to have like a JSON and a API behind that? So like I said, oh yeah, no problem. Like me with my big French, and I said like, how I'm gonna do that? Because the cool stuff is like, I already have a topic which like give me a JSON. So I just had to expose that topic into a REST endpoint, and in like 2 hours, I had the entire like answer. I had an API where you can just like send a query in natural language and get the JSON back document, right? So it was like very, very easy. The usability and reusability of your data when it's inside the platform without any much effort. Here we go. I'm just gonna play the video. It's here. Oh, it's here. She said like the Wi-Fi is not particularly great. I can do a try. I do the demo first, and then I do a try live. Disclaimer, my partner is a voice, because she has much better accent than mine.
Hello.
Oh. I don't know if it sounds.
Hello, how can I help you today?
Show me the providers in a 5-mile radius of my location who have a lower than 15% success rate in PAP approvals.
This data identifies healthcare providers within a 5-mile radius of a specific location who have a low success rate for something called path approvals. There is one provider listed, Daniel Strand. They had 2 cases and none were approved, resulting in a 0% success rate.
And after that, you can see that the same thing we do, well, different requests. Obviously, instead of like 5 miles, I said 100 hours of driving, just to test that geolocation works. So we did like, we sent that through an API, and then you get back the data, and more because I asked also the LLM to give me a explanation of what the query is about. So like it's very interesting the way it works. In one prompt, I was able to get like the SQL query and the description of the query itself and the schema, right? So because we have plan of like exposing that to a BI tool, Looker Studio, later on, so where you can say, hey, can you generate a dashboard with those data, and automatically your dashboard show up in Looker Studio with like the right schema and things like that. Sorry, wrong screen. Bloop.
And while he's working through that.
Show me the providers in a 5-mile radius of my location who have a...
And just to put some context to the usage model of that, it seems simple, right? But there's multiple use cases for that. As a patient, right, and you're uninsured or got no insurance, you need to get on this drug, and it's a complicated process. You need to go to a physician who's successful, knows how to work the system to get things through. So it provides better outcomes for the patient and more information to make a good decision. On the flip side, for a big pharma company that supported these programs, they can look at that and their field reimbursement managers can say, oh, I'm going to give extra training to this physician here and to these office staff because they're obviously having problems getting through the process. You know, so from both sides, you can improve the patient, be it from the big pharma side, you can direct their marketing dollars and education and training dollars to the physicians that need it. And it, just from something like that, again, can save millions of dollars and really increase the patient outcomes and get people on treatment.
Yeah, so for the conclusion, like, so what happened is like in a very short time, we were able to have a voice to text to SQL to text to voice again, right? So we used twice Gemini for that. One was to generate the SQL query and some description, And then when I have a table, I ask Gemini, can you just like give me a summary of that table? And same thing, we had like a lot of like the prompt to explain. I don't want you to tell me like big number, because like the NPI number is like 1 billion. So I had like 1 billion, blah, blah, blah. It was like very interesting. So like you tune your prompt as you go. Again, as a summary, data, 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 data. LLM is all data oriented and as fresh as you can to give the best experience to your user. The prompt, super important. Like you need to be able to tailor your prompt as you need and as you go, and the testing and A/B testing is super, super important, and then you will be successful.
Thanks, guys. So just to summarize this, there's some key takeaways here, right? Healthcare in general is an industry that needs this technology to improve it, right? To create automation, to create cost savings, to get people the treatment they need quicker, to analyze that treatment for adverse effects or how well the treatment's working. This all comes into play. You extend that to IoT monitoring devices to get more input coming in. So it's data, data, data. More data coming into healthcare. And I know that's hard with regulation sometimes, but more data coming in, then we can create better outcomes. So some of the takeaways, I'm all sure you're going to remember the Three Musketeers. So the Three Musketeers of healthcare is what we are. And it's the Google platform with AI driving it. It's a Confluent platform for data streaming and processing. It's Cardinal Health's experience in this space and building enterprise systems, working with our partners in big pharma, physicians, and obviously patients as well. So I think Alexander Dumas, if he was writing a book today, right, he'd want to tell this story because it's a great story. And at the end of it, people get the healthcare they need without breaking the bank. They get treated. It doesn't cost them a fortune. It's cost reduced. It's optimized. And the quality of the healthcare and the treatment is improved. So quoting my inner Alexander Dumas, right? I think you all remember the Three Musketeers quote, all for one and one for all. I think today's modern quote, he maybe say, it's AI. It's not all. It's AI for all for AI. And I think that's the future as we go forward. So remember the Musketeers, remember that quote. And as these guys were telling me, we had so many crazy ideas that we want to do, but they're not crazy. All crazy ideas are brilliant, right? So please come and check us out at future conferences, because this idea, join us in it. We invite you all to come and join in it, right? Healthcare is a big space. We need everyone to come in and innovate. There's so much stuff to innovate. Help us get the data out there. And we will take a couple of questions, but the Three Musketeers would like to thank you all for your attention today, and au revoir, and we'll see you all again.